Alright, so today we're going to look at factorization of polynomials again. So we did this yesterday, but we're going to be looking at this theory, or the remainder theorem. So let's just practice what we did yesterday and have a look what we happened, because I'm going to show you something about it. Alright, so up here we've got the polynomial here, and they want us to divide it by this linear expression here. So what you do is we write out the linear here, and then we've got our division, and we put our sorry, that should be cubed there. This one should be cubed. Plus 3x squared plus 2x plus 1. Okay, so essentially the first thing you're doing is you're saying you're dividing x cubed by just this x here. So what's x cubed divided by x would be x squared. Once you get that number on the top, so the x squared then times with everything over here in this linear expression. So we've got x squared times x will be x cubed, and then what's x squared times negative 1? Negative x squared. Good. Now you've done that, you're going to minus that. When you minus it, you should see the leading term disappear, which we do, because x cubed minus x cubed is what? 0. So then I'm looking here, I've got 3x squared minus x squared. What would that be?
4x squared.
Oh yeah, because it's a minus and a minus. Good. So because of this minus here, minus there, so 4x squared. Now what we're doing is we want to sort of do the same thing again, but we're going to bring this down so it's sitting there, so I have a term later to just subtract. So what we're looking at is we're dividing this 4x squared by this x here. So what would that be? 4x squared divided by x is, so up here on the top we say the answer is 4x. And now you're going to multiply out. So what's 4x times x? 4x squared. So can you see we created that so we can lose the leading term? Then we've got 4x times negative 1, which is? Negative 4x. Good. So now we can subtract them, and we see that leading term disappear. So what's 2x minus a minus 4x is? 6x. Good. And now we'll bring that 1 down so we can do the last bit again. So we've got what is x, 6x divided by x. So plus 6, yes? So what I did there, just so you're aware, I did this 6x divided by that x, and I put the answer up here, yeah? And now we times out, so 6 times x is 6x, and what's 6 times negative 1? Negative 6. So we subtract that, and what do we get? A 7. So essentially this is, what do we call this? This is the remainder. Good. So we saw that when we divided that polynomial by x minus 1, we got a remainder 7. Now let's go practice another one over here. They want me to divide it by x minus 2. So once again, x minus 2, draw the division template, x cubed plus 3x squared plus 2x plus 1. So, I'm doing this to help you. So x cubed divided by x, what's the answer? X squared. Then you multiply it out. So what do we get? We get x cubed minus squared, and then we're going to minus it, so then the leading term's gone, and then we've got 3x squared minus a minus 2x squared, which is 5x squared. Now what's my next step? Good, bring that 2x down, and then do the division, yeah? So you go 5x squared, divided by x is plus plus 5x. Then multiply them out. So 5x squared minus 10x, because the 5x thing. So we're going to minus it. Okay, so we're minusing now. So that is 2x minus a minus 10x, which is 12x. Now what do? Bring that 1 down. Yeah? And then we're going to do 12x divided by x, which is plus 12. And then multiply out. So we've got 12x minus 24. And then what's our remainder? Good. So 25. So here you're telling me when you divide, you have a remainder of 25. Okay. So we've looked at this. When we've divided by x minus 1, we got a remainder of 7. When we divided by x minus 2, we got a remainder of 25. Now I want to show you, if we go to your divided by x minus 1, I got a remainder of 7, the same as when I do p of 1. And when I divide by x minus next page, you obviously can see this. Yeah? Now it says evaluate when you have p of 1. So what p of 1 means is every time I see x in that polynomial, this was the polynomial, 3x squared plus 2x plus 1. Every time I see x, I'm going to put a 1 instead. So 1 squared plus 2 times 1 plus 1. So if you have a look at that, that would be 1 plus 3 plus 2 plus 1, which equals 7. So when I did p of 1, I got 7. Now look, if I do over here, if I do p of 2 into my polynomial, this is the same as the one before. Look what I get. So it'd be 2 cubed plus 3 times 2 squared, 2 times 2 plus 1. So that would be 8 plus 12 plus 4 plus 1, which equals 25. Did you notice that they are the same as those remainders on the other thing? Yeah? So when I got the remainder. So what we can say is, and down here, I'm saying that, when p of x is divided by, see, x minus a, the remainder is equal to the same as when you do that. So I'm saying when I divided by x minus 1, it equaled the same as when you did p of 1. So when that's minus, that's 1. So when I did x minus 2, that gave the same as when I did p of 2. So therefore, if I divided by x plus 1, yeah, it would give the same as if I did p minus 1. Does that make sense? It's the opposite sign. Yeah? See how here was negative 1, but I did p of 1. But here I did plus 1, I did p of negative 1. Do you get what I'm saying there?
Yes.
Yeah. So here we're just summarising that. That's called the remainder theorem. So you can know what the remainder will be. So when p of x is divided by ax plus b. So when we had our little example, we divided by x minus 1. So our a would have been 1 and our b would have been negative 1. So it's saying when you divide by that, it'll give you the same remainder as if you did that. Now, if you have a look, if I did that, if I did p negative 1 over 1, that equals, b was negative 1, so negative, like that. See how it ends up being 1 over 1, which is 1, which we said. We said when we divided by this, we got the same as when we did p of 1. All right, so it says use the remainder theorem to find the value of the remainder when this polynomial is divided by 2x plus 1. So we don't have to do that long division. All we have to do is we can see that a is 2 and b is 1. So it will give me the same remainder as if I do negative b, so negative 1 over a, which we're saying is 2. So can you see that simplifies to be negative a half? So I don't have to do that division. I just have to put negative a half in. Yeah, so let's go do that. We know the polynomial is this. So it'll be the same, It'll be the same as negative a half cubed minus 2 times a half plus 4. So remember when you cube a fraction, you've got to cube everything. So that would be negative 1 over 8 minus, what's this going to be, 1 plus 4. So, and then you can just keep, like, simplify that. And it'll end up being 39 over 8 remainder. So you keep that. All right, so that's quicker. Good, so you're saying this should be negative. So that would be plus 1. Yeah, so we end up with what, minus 1/8 plus 5. So 5 and 8 would be 40 over 8. Yeah, so whoops, the answer's right. Still that. Okay, good. Okay, when p of x is divided by x minus 2, the remainder is 4. Find the value of a. So if you're why is my pen not working? Wait a second. I think he's lost charge. I'll just charge it. Pardon?
Is that because like 80 bucks?
What?
A pen?
I don't know. The workboard, of course. Came with the iPad.
Oh, it still gives you iPads.
They did for me, because we're testing this learning out. This is the way of the future, they reckon.
How long have you been like
That's start last year.
It's actually a terrible way.
this? Have you noticed an improvement?
Yeah. We noticed massive.
Really?
In this class?
Yeah, like the failure rate is not as high as what it was. Because you can go watch it again. It was the note copying that makes it too hard. You guys need me to help you with questions. See how we do more questions? That's where you need me to help. Before I was doing whole lessons writing notes. What's the point of that? Because some kids will turn off. That's another person explaining. But some people need, because we've noticed the videos don't work unless it's me telling my class. So some people, like some will like it, but unless because you know it's me, you can hear my voice, and you get used to the way I explain it. But say Ed Rollo's some random, and he might use an expression I don't use.
Why don't you just use the videos again?
Pardon?
Why don't you just use the videos?
I did.
You did?
Yeah, they're all last year's.
Okay.
Yeah, some of them, but this one I missed. I don't know why. Because it was new. We hadn't done it. All right, let's go. I'm back on. She's back on. Yep, so when p of x is divided by x minus 2, the remainder is 4. So you can see you've got a little unknown in there, and you've got to find the value of a. So you know when you divide by x minus 2, it would be the same as if I did p of 2, wasn't it? Yeah? Remember? So I'm going to try p of 2 first, and that would be, so this is the polynomial, and if I put p of 2 in there, it would be 2 cubed plus 2 times 2 plus a. So you end up with 8 plus 4 plus a, so you got 12 plus a. So you know that, but they told me that the remainder was 4. So I know, therefore, I know 12 plus a equals 4. And then can you solve for a? A equals 4 minus 12. A equals minus 8. Excellent. All right, so let's go with the next one. They said it has a remainder of 17 when divided by x minus 3. So we know the remainder of x minus 3 would be the same as p of 3. So we can go out and do that one again. So we'll go p of 3 into our polynomial. Now they won't give you big numbers if you've got you don't have the calculator. If you've got your calculator, we can give whatever we want. But these numbers look like non-calc numbers, so you should be able to do all of that.
So easy.
So 3 cubed is 27 minus 27, because 3 squared is 9 times 3. Then minus 3a minus 5. So, yep. And then we end up with minus 3a minus 5. And we know that this equals 17. So you got 17 equals... Yeah, sorry, you're saying that's plus. I've missed that. Yep. I wrote that down wrong. Yep. So we got plus 3a minus 5. That equals 17. So you can keep rearranging. So 17 plus 5 equals 3a.
22 equals
So 22 equals 3a, and 22 divided by 3 equals a. You can just leave it like that. I think it was supposed to